This is the third and last of the introductory lectures that normally would take up one 50-minute in-class lecture. And now I'm just going to talk about in general the different components of the course, what to expect, and how we'll handle them. And we can be flexible, so if this doesn't work out after a week or two and you guys are all giving me that information, then we can work out how things can be modified. But I believe this should be a reasonable plan. So first of all, live lectures, yes, we'll have them 3 times a week, Monday, Wednesday, Friday, just like you were taking a class. Times are going to be determined by the doodle poll. I suspect we'll get into the times that were originally scheduled for the course, but I don't want to assume that that's good for everybody anymore. Some of you may have signed on to an in-person course since you had that time slot freed up, so I just want to make sure we're not missing anybody. As a rule, Monday, Wednesday will be the course material, like I showed you on the schedule, and we'll have text from the textbook and from other sources, and then Friday is going to be project information so that we can do some explanations, some examples. I have good, bad, ugly examples of what kind of work I'm expecting, and we'll do workshops also. Some of that will be peer review, where I'm going to ask you to be brave enough to show your work to other people before it's done so that they can give you feedback and improve the work. Now, the way you should be hearing that is you're going to give your work to somebody and they're going to help you get a better grade, because that's how that works out. First week is reversed, right? So we're doing our non-course material today because of the intro, and then we'll do textbook stuff from Wednesday and Friday. Okay, again, attendance is not required, but my experience is students who don't come to class just miserably fail the course. It's not one of those where they don't come to class. Usually if students don't come to class, they're either a high A or a bad F. I don't get the high A students. Now, it may be a little bit different with these lectures. So if you're reading, if you're hearing these lectures that are recorded, first of all, I'm sorry, right? It's not an easy thing always, but if you're hearing these lectures that are recorded and you feel like you've got it, that's great. But I would much rather, if you had any concerns or gosh, I wasn't clear about that, I'm not sure what Garfield's talking about here, by all means come to class and then ask those questions. I'll also have some office hours and I'll vary those times throughout the course. The labs, now when you had to sign up for this class, you signed up for CS225 and CS225L. We're only going to use the Canvas CS225 for everything. So don't worry about your CS225L in Canvas. That won't be published, it won't be populated. Everything's going to happen here in CS225. We've done that for years in a row and it always works out fine. So Dean will have access to this course and he's going to put up all of the lab materials for you, including any video lectures that he does. No labs for the first week of class. There will be labs the rest of the weeks, even though I have that glitch in my preliminary schedule. Dean Laga, as I said, runs the labs. He's very good. He's been doing this now for 3 or 4 years, and he's a real pro at it, and he's worked hard to make the labs much better than they were when he found them. The idea of the labs is to give you an opportunity to focus on a specific small skill, right? So writing methods, which is what we call functions in the object-oriented world, or doing some graphics, or testing software, or debugging software, or writing a UML diagram, some small specific skill that gives you an opportunity to practice. And then the homework will reinforce that, and then your project is showing us that, hey, I really got it, I know how to do it, and I know how to do it in the context of some larger piece of software that I'm developing. At the end of the semester, the last few weeks, then we don't have lab, and those are reserved for tutoring and project help, and the lab overall gives 300 points to your LHQ grade. Homework assignments. The most important thing to know, late homework is not accepted. There's too many students, and our grader would be overwhelmed if we kept having that person go back and pick up assignments that they didn't get earlier, particularly towards the end of the semester. So this can't be a thing where at the end of the semester you throw in 5 homework assignments and say, okay, give me my points. Once the due date is passed, then it won't be accepted. Now, we're going to give generous due dates, right? You will have time to work on this stuff. But be aware, the deadline is the deadline. Now, please don't be the person that says, oh, I tried to turn it in at 11:55 and my computer died or my power went out or my whatever. Don't be that person. You know it's going to happen, right? So turn your homework in. Early is always better. Always. Now, I know that's hard. You're a student. You got a lot to do. But early is always better. Try to have your homework done early in the evening it's due, or preferably that morning, so that way you don't have to worry about it, all that good stuff. There's 8 required homework assignments and 1 extra credit assignment. Everything's going to be assigned and submitted via Canvas. 6 of the 8 are coding assignments, and they actually all go together. So what we've done is developed basically a mini project. We call it the Hare and Hound. And the hare is, this is actually a thing in ballooning, the hare and hound in ballooning, where one balloon goes out, that's the hare, and then all the other balloons chase it, they're the hounds, and whoever gets closest to the hare, wherever the hare landed, they win. So it's that kind of thing. You're going to be simulating a balloon race or a balloon chase. So we start out small and build and build and build. Now the first 2 assignments are not part of the hare and hound because it's just, here's some basic skills. But once we get into that, then you're going to build, okay, here's a basic hare and hound. Here's a more complicated hare and hound. Here's a hare and hound with animation. Here's a hare and hound where the user can actually control what's going on and play the game. It's a mini, like I said, it's a mini project. Technically, if someone did that for their project, you can't because it's already being done for you. If someone was to do that for their project, that would fulfill all the project requirements. So that also gives you an idea of the kind of project that we're looking for. The homework contributes 200 points to your LHQ grade. And did I mention that late homework is not accepted? It is not accepted. The project, now this will take up a fair amount of time in your course. That's okay because we're going to start early. You look at the schedule, you turn in your first deliverables early on, and the project idea here is for you to take what you've learned in your previous programming course and in this class and build a, quote, relatively sophisticated. By relatively sophisticated, I mean this. It's probably more sophisticated than what you've programmed in the past, probably, as an individual at least. But I'm also recognizing, you're just one person and this is just one class, so I can't ask you to build these giant pieces of software. So it's a mixture there, right? It's sophisticated enough where you run into the kind of problems that you have when you build large pieces of software, but small enough to be contained within the semester. Quite frankly, because I do let students pick their topics, most students pick topics that are too big. And so I have to negotiate with them and say, okay, wait, you're never going to get this done in this semester. Let's pull back. Let's reduce the scope of this project. And then when you want to, after the semester, then you can expand it to what you wanted it to be. But for now, let's just make sure that you can finish it on time. There are 4 major requirements. They must use object inheritance. You may not know what that means right now. Well, that's why you're taking the course, right? So we're going to cover that in the course. You must have a graphical user interface where you're going to the user interacts with the software only through the graphical user interface. And it has to use JavaFX. We'll talk about this as we go through. Has to use JavaFX. That's a specific style in Java of creating the GUI. And then you must have exception handling to catch errors, at least one place in your program. So it doesn't have to be everywhere. Now that's, by the way, that's part of good programming practice, is to try to catch all the errors. And these days it's not just good programming practice, it's about software security. Being able to maintain control of your software when people try to do funky things to it to screw it up. Because that's how people try to break into systems, is to basically break the software, make it act funky, and then slip in some kind of a backdoor that the designer didn't know was there. And you must have file input output somewhere. It doesn't have to be a major thing, just show that you can create a file, write to it, read from it. Those are the 4 main parts of the project. We'll talk about this quite a bit as we go through the course. You choose the topic with limitations. And the basic limitations are I've banned all the popular games, Tetris, Blackjack, Othello, Battleship. And the reason is, if you wanted to do those and now you're upset, you got to blame the people that took this course before you, because the plagiarism rate at people that picked those topics was like 70%. I mean, it was a high number. So I'm just getting rid of that temptation and that annoyance and headache. None of those games. And that's listed in the topic assignment, so you'll know. I also have a list of ideas. So I have some ideas that were given to me by other faculty members, some that I have for my own. I asked the faculty in human factors, hey, if a student built a tool, what would you need? If they built something for you, what would you need? And I have a list of those. And so what I'm going to do is I'll expand on this as we talk about the topic more, the project more. But if you choose those and you can get a faculty member to vouch for you, basically there's some extra credit assigned that goes along with that assignment. So if you're actually doing a product for a person in that context, then and they actually, at the end of the semester say, yeah, this person did a good job, then you get extra credit for the project. And we'll go through those details. The reason I want you to choose the topic yourself, though, is I want you to be excited about it. I want you to be something that you chose because you're interested in it. So, again, we'll talk about lists of topics. I am always pleasantly surprised at the variety of topics that I get from students. It's all over the place, and it's great. The topic is chunked up into 7 deliverables. The first one is just, hey, here's what my topic is going to be, so that we can talk about it and make sure that you're not, trying to do too much. And then as we go through this design document, test and requirements document, a performance planning and tracking sheet, and then the actual software. Remember, when you're creating software, you're never just creating software. You have to also create software plus the documentation of the software. That's true in the real world, and it's true here in academia. In the real world, when you're working on a software project, that software project that you built today might still be alive 20 years from now. And if that means other people are going to work on it. You're going to be on the project, you're going to leave, other people are going to come on the project. And if you don't leave them enough hints as to what you were doing with your software, then it's worthless. They can't continue the project. And some of you, maybe all of you, have experienced this. I know in the past I've had, okay, I built this software to do something, and then someone else wants to use it. Hey, you did something like that, Garfield. Let me borrow it, and I can just expand on it. And almost always they're going to have to just trash it and start from scratch. And it's happened the other way around, where I'll say, oh, so-and-so built this software. I'm going to use it and expand on it. No, it's easier to start from scratch. This is an implicit problem with software. Like I said, software engineering is implicitly difficult, and that's one of the difficulties. The idea behind the project is you are practicing, again, go back to those themes. You're practicing object-oriented software design. You're practicing new software development techniques so that you get better at creating sophisticated pieces of software. And you're learning how to do documentation appropriately. That is not just putting comments in your code. In fact, I'm going to try to talk you out of putting comments in your code. It's about putting the supporting documentation alongside the code so that people can understand what you did, how you did it, why you did it. And if they need to take your software and do more work with it, they are able to. The project contributes all 400 points to the project grade. Remember, the grading is into 2 chunks, the LHQ chunk, that's the lab homework quiz chunk, and the project chunk, and the project is a 400-point chunk. Okay, that covers the basics of the course. So I hope you have questions. I hope you bring questions to the live session, and I will see you on Monday, and have a wonderful weekend.